everybody, I'm Poppy, and I love physics.
Yeah, and I can keep that voice up the whole time, don't you worry. All right, we're going to go ahead and we're going to do one more video with the electric fields here. We're going to see the effect of those electric fields and start looking a little bit at circuits. Sadly, we don't get to do a lot with circuits this year, but I'm going to give you a little bit of a taste of it so that you have an idea of kind of what we look at if we were able to do a little bit more of that. You've had a chance to look at batteries at this point, right? And you know that when you have a battery, that there's a chemical reaction inside that maintains a positive charge on one side and a negative charge on the other side, right? The positives are not allowed to go directly through the battery, and so therefore you just end up having a positive side here, a negative side here, and they just hang out until something is done to allow that negative charge to move from one side to the other. All right, so we're going to go ahead and do that. We're going to go ahead and create, we're going to put a wire on there. I know this is a fancy wire. Now, what I want you to see is this. If I have a negative here and a positive there, then there is now an electric field, right? Anytime you have a positive and a negative, you may remember when we had the parallel plates, right? When we had the positives and the negatives, we said the field went from the positive to the negative and then on the outside like that, right? There was a force, basically a force that could exist inside of that field going from the positives to the negatives. You may remember that when we had a positive charge and a negative charge and we drew that field, right? We drew the field here and we said this goes out like this. This one comes in there, and so when I put them together, I end up with this force, this field that goes from the positive to the negative, from the positive to the negative. All of this has kind of been building up to this point right here, where I then have field going away from the positive into the negative, and very often away from the positive into the negative, right? That's what the field does. It goes from the positive to the negative. So what happens when I connect a wire here is I've got a positive here and a negative down there. And so it creates a field that goes from here, pushes this way, and then up that direction. All right. Now, what happens is that there are electrons inside of that wire. Okay. A very common misconception that people have is they say, oh, so the current, those electrons, they start here and they've got to flow through the wire like that to get to the positive. No. We're starting with electrons in the wire. There are already electrons there. And so when you connect it to this battery, the electrons that are here, they're already moving into the positive side of the battery. Yes, there are new electrons that are going to move in here, but what we have is it's actually all of the electrons that are in the wire, or at least the free electrons here. Those guys are all moving around the circuit, right? And that's an important difference because what that means is that all of the circuit feels the current at the same time. It's not like when you turn on the hose, the water has to go from this point to that point to that point, and it kind of flows down the river that way, right? What we're saying is that these electrons are all over in the first place, and when we create a field there, right, a field that goes from positive to negative, meaning that the negatives will go the opposite direction, that means all of these free electrons will move at once, right? Not just the electrons that are in the battery, but all of them. So the whole circuit here, circle, right? It kind of goes together. So the circuit starts and ends and basically creates a loop, right? And so what we're seeing here is that all of the circuit feels the electrons move at the same time, all right? So that's kind of a cool thought just to kind of start off with. Now what we have here is something that we call direct current. Okay, which means that the current is always traveling the same direction, right? I hook this up, the current, the electrons will always flow this way, kind of a weird thing is that when we talk about current flowing, we actually talk about current flowing in the same direction of the field. So even though the electrons are going this way, we actually say that current is this way. All right. So don't be too confused when somebody in a video or in your textbook or in some future physics class talks about current. They're talking about the positive, which goes in the same direction as the field, from the positive to the negative. Positive to negative. That's the current that they're talking about. What you have to understand is that positives aren't really moving. What is moving is the electrons. All right? And the electrons are moving the opposite direction. They're going from the negative all the way up to the positive there. All right? But this is direct current because the current always flows in this direction. That's one of the nice things about batteries, other than the fact that they can just store energy and we can use them anywhere, right? There's another type of electricity, which you've probably heard of before, and it's called alternating current, AC. This is DC. I know some of you now saying, AC/DC, that's a band. No, I'm not talking about the band. We're now going to talk about alternating current. AC. And that's what comes out of your electrical sockets. And we say out of, but it's a little bit weird because AC current doesn't flow like this. It doesn't go from one place to the other place and just continue to go in that circle there. Alternating current does this. Here's my wire again. I'm going to put an alternating current generator here. This could be the generator at your power station. This could be the generator. This could be just kind of the outlet in your wall. Where is the electricity coming from? Okay, now the idea of an alternating current, remember still we have these electrons here. The electrons were already in the wire, and this again is an important idea, especially for alternating current. So the way that alternating current works is that this will create a field going one direction, right? So it may say, all right, first I've got a field like this. So the positive is up here, the negative is down here. So the field is this direction. So current is that direction, but the electrons are all going to move in the opposite direction. Electrons are all going to go this way, just like this. So there go my electrons. They're going that direction around the circuit. All right, and maybe some new electrons come out of here and join them. Okay, but after a short time, very short time, the field switches and goes the opposite direction. And so now instead of being plus and minus, the field is now going to be minus on top and plus on the bottom. So what are the electrons going to do now? They're actually going to go towards the new plus. So instead of going down, they're now going to go back, right back to where they started from. They're going to go right back down. Because now they're going the other direction. Because they're going away from the negative towards the positive, which is now this way. And so now my electrons are flowing the other direction, my current's flowing the other direction. Now you may say, well, if the electrons are just going back and forth, how does that even run anything? You know, how does that work my TV or my computer or whatever else? Well, some things it doesn't work. Some things it does. For example, a light bulb. A light bulb is just the old-fashioned light bulbs, and these as well. Light bulb is just getting something to heat up, right? And so if you have one of those old light bulbs, as the electricity goes back and forth, it's going to cause your filament to get hot and glow, and it's going to create light. It doesn't matter which way it goes, right? Same thing with a lot of things is the direction doesn't really matter sometimes. As long as I have moving electrons creating energy and creating heat, that's all that matters. And if that's all that matters, then AC current works great. In fact, it's a lot easier to produce, which is what we'll look at the end of this unit. All right? Now, there are some things that need the current always flowing the same direction. like your computer, right? Your computer, you can't have current going one way and then switching and going the other direction. That's what the little black box is for. You've probably seen this, right? That's what this is. This does a couple of different things, actually. One thing that this does is it turns that alternating current from the wall, it turns it into direct current. There's a specific thing going on, and there's some diodes and usually a diode rectification bridge. There's other ways to do it, but usually something like that, some capacitors that then turn that alternating current into a direct current situation. All right. This also can change the voltage, which we're not going to worry about right now. That's beyond what we want to study in this class. But this box is really, really important. And you'll notice a lot of devices have that, especially if you're able to use them both when there's 110 volts, like in the US or in the Philippines, or 220 volts, like most of the rest of the world. Okay, but it also helps with that conversion of AC to DC. Something like your TV, which you aren't really going to be transporting around, it might be built into the TV, that thing, that rectifier circuit that turns it from an AC current into a direct current. But certainly there are a lot of things that the DC current works much better with, or only works with direct current. All right, let's see. I've been using the word current a lot. I want to make sure that we have a clear definition of current so that it makes a little bit more sense as we discuss, especially as we go into the next part of this unit. Current is resembled with an I, a capital I. Don't ask me why. I don't know. I'm sure it's something Greek or something. So current. And current is defined as the number of charges passing through a specific location in an amount of time. All right. Now that could be choosing a location here and counting how much charge is going through there. Now charge is in units of coulombs, just like it has been in the rest of our unit. So looking at the amount of charge passing this area. So if it's direct current, you just count how many are going by there and how much charge is going by there. In alternating current, we will have a current in one direction for a certain amount of time, and then we'll count the current in the opposite direction. If you were to add it all up, it would add up to 0, right? Because the current's going back and forth, back and forth, back and forth. And in the long run, there's no change there. There's no displacement. But over a short amount of time, you do get usable energy. All right. So the only other thing that I think we should add on here is we know the units for charge is coulombs, and the units for time is seconds. And we do have a new unit. Coulombs per second is amperes or amperes, depending on who you ask. So that will be the unit for current. You're not really going to do much with current. I just wanted you to be introduced to it so that when you do see it, we are going to talk about it a little bit in the next part of this unit. At the end of this unit, we'll be talking about current and fields and forces and how they all kind of interconnect. But I wanted you to make sure to be introduced to it right now, so it makes a little bit more sense then. All right. So hopefully that is helpful in introducing you to what current is, how we can create a direct current from a battery, which again creates a field, which then causes the electrons to move. That's the important thing. That's the connection to what we've been talking about, why fields are so important, because it can cause electrons to move. And if it causes electrons to move, we got energy, right? That's the important thing here. Then we've got the alternating current, which is a device or some set of things that then cause the field to constantly change from one direction to the other direction. And we'll see that in the next unit. That's why I wanted to make sure you've at least seen it and you know the difference between the two scenarios. One, which is a battery, which always goes the same way, direct current, and the other, which is something else, which creates a field that keeps changing direction, which then means that the electrons go back and forth. And remember, the big idea, one of those big takeaways, is that the electrons don't have to go all the way from here, all the way to there, and then all the way back, and then all the way here, and all the way back. It's just the same electrons that are being forced one way to the field, and then forced the other way to the field. And then this way, so it's the electrons that are already there, but we can get them to do work and we can get energy out of them. All right. Okay, that's it. And you're about ready to go on to the next part of this unit. We'll see you then.